Our goal is to minimize the number of stamps, which is the number of stamps of postage A, postage B, and postage C. We need our first postage value to be equal to 1 cent because that will cover all the postage values up to B minus 1, where B is the second highest postage value. With our 1 cent stamps, we can produce postage from 1 cent up to B minus 1 with B minus 1 stamps. Then our next stamp has to be B, and so on. We are searching for the 3 least values of C, and since C must be greater than B, the smallest value of C is B plus 1. So we'll start with this value, which means B is less than or equal to C minus 1. Since we want to minimize our total number of stamps, we only need 1 stamp with value B. For higher postage values, we can add multiples of C and B, and then all of these 1 cent stamps over and over again until we get to 1,000. This means the number of stamps with value A and B is going to be B minus 1 plus 1 more stamp of value B. Substituting here, we have that the sum of our 2 smaller stamps is less than or equal to C minus 1. Now let's see if we can get an expression for the number of stamps with the value C. To do that, let's just start with an example. Let's say A is equal to 1, B is equal to 6, and C is equal to 7. Since B is worth 6 cents, we need 5 1-cent stamps to cover all the stamps from 1 to 5. We only need 1 6-cent stamp. Now let's see how many 7-cent stamps we need. We're going to look for a pattern in the number of 7-cent stamps for different values from 1 to 1,000. To have enough postage worth 1,000 cents, we need an even 142 7-cent stamps and 1 6-cent stamp. For 999 cents, we're still going to have 142, but now we'll take 5 1-cent stamps and no 6-cent stamps. And we'll continue this down. 1 less cent means now we're down to 4 1-cent stamps until we get an even multiple of 7. Now we just need 142 7-cent stamps and nothing else. When we get to 993 cents, we need 1 fewer 7-cent stamp, and we'll replace that with a 6-cent stamp. Now NC goes down to 141. This is the last value where we can use 141 7-cent stamps. It seems like every 7 values, we're going to need an additional 7-cent stamp. This suggests our formula for finding the number of 7-cent stamps. We're going to take 1,000, divide by 7, and then round down. Generalizing, we're going to take 1,000, divide by our third value of stamp C, and round down. And this is going to be the upper bound on the number of stamps of value C. As we'll see later, we can sometimes achieve a smaller number than what is indicated by this formula. So we have 2 inequalities that we're going to use to test our cases. Our last restriction is that the sum of our 3 kinds of stamps is equal to 97. The sum of these 2 inequalities can be written like this. So we have this expression is greater than or equal to 97. Let's multiply this by C and collect all the terms on one side. The floor of 1,000 is just 1,000. We're looking to see where this quadratic is positive, so let's find the roots first. Using the quadratic formula, we get C is 49 plus or minus the square root of 1401. This square root is between 37 and 38. So our smaller root is between 11 and 12. Since C is an integer, we're going to look for values of C that are less than or equal to 11. Our larger root is between 86 and 87. And since C is an integer, we're going to start looking at 87. Let's start first with case 1, C is less than or equal to 11. Let's first try C is equal to 10. We have at least one of stamps valued A and B, so at a minimum, we have 95 stamps with value C. If we have 95 10-cent stamps, that gets us to 950 cents. We can add to that a 9-cent stamp because B at most can be equal to 9. And then we can add to that 8 1-cent stamps to get us a value of 967 stamps, which isn't enough to get us to 1,000. So C equals 10 fails. We'll try C equals 11. First, with 95 11-cent stamps, we can get up as high as 1,000 cents. Let's test our inequalities for the number of stamps. Our first inequality is that the number of stamps of value C is the floor of 1,000 divided by C. This is 90. So NC is less than or equal to 90. The number of stamps valued 1 cent or B cents must be less than or equal to C minus 1. So this inequality is less than or equal to 10. We can list these out with a table. NA plus NB can be as high as 10, which means NC has to be 87 in order for these to add up to 97. We fill in the rest of these values until we reach our maximum value of NC, which is 90. If any of these values satisfy our condition, then we will have found our first value of C. Let's start at the bottom and try NA plus NB is equal to 7. This is equivalent to B equals 7, and the number of 1 cent stamps is equal to 6. We need to have NC is equal to 90, and we want to make sure that we can't achieve all 1,000 values of postage with a fewer number of 11 cent stamps. With 90 11-cent stamps, we get 990 cents. If we take those 90 stamps and add a 7-cent stamp and 3 1-cent stamps, then we can get 1,000 cents. Let's make sure that we can't do this with fewer stamps, because we need to minimize NA plus NB plus NC. So let's see if we can't get 1,000 stamps with just 89 11-cent stamps. This gives us 979 cents worth of postage. If we add in our 7-cent stamp and all 6 of our 1-cent stamps, we get 992 cents, which doesn't cover all the postage that we need. So indeed, our minimum value of NC is 90. We have values that work, and we found our first value of C, which is 11. That's it for this first case. So now we'll look at the second case where C is greater than or equal to 87. We'll start by trying C equals 87, and we'll test our inequalities. The number of 87-cent stamps is less than or equal to 11, and the number of 1 cent and B cent stamps is less than or equal to 86. Since 11 plus 86 is equal to 97, then these are our only values for NA, NB, and NC. That means B is an 86-cent stamp, and we have 85 1-cent stamps. Let's make sure we can't use fewer than 11 87-cent stamps. We'll see what happens if we only have 10 87-cent stamps. This gives us 870 cents. If we add in our 86-cent stamp and 44 of our 1-cent stamps, we can get 1,000 cents, which means that the sum of the number of stamps is not minimized when we have 11 87-cent stamps. So this case fails. Let's try C equals 88. Again, we'll plug into our inequalities. NC is less than or equal to 11, and NA plus NB is less than or equal to 87. With these inequalities, our possible values are 11 and 86, or 10 and 87. Let's try our first case. This means NA is 85, and B is 86 cents. And we have NC is equal to 11. Let's see if we can get all the values with NC is equal to 10. This means we have 10 88-cent stamps for 880 cents. We can add to that our 86-cent stamp plus 34 of our 1-cent stamps to get 1,000. In this case, we can get away with fewer than 11 88-cent stamps. So this case fails. We'll try case 2. Here we have 86 1-cent stamps and an 87-cent stamp, but only 10 88-cent stamps. Let's see if we can get away with 9 stamps of value 88 cents. If we add on our 87 and our 86-cent stamp, we only get 965 cents. Therefore, at a minimum, we need at least 10 stamps of value 88 cents. With 10 88-cent stamps, an 87-cent stamp, and a 33-cent stamp, we get 1,000 cents and our next valid value of C, which is 88. Let's try C equals 89. Plugging into our inequalities again, listing out our valid values of NA, B, and C. Let's check this one first. Here we have 87 1-cent stamps. B is equal to 88, and we have 9 89-cent stamps. We'll check if we can achieve this with 8 89-cent stamps. All of our stamps generate 887 cents worth of postage, but if we have 9 stamps of value 89 cents, we also have inadequate postage. So let's try the second case. Here we have 86 1-cent stamps, a stamp worth 87 cents, and 10 stamps worth 89 cents. We'll check NC equals 9. Using up all of our stamps, we get 974 cents worth of postage, which isn't enough. When NC equals 10, if we use 10 of our 89-cent stamps, our 87-cent stamp, and 23 of our 1-cent stamps, we get 1,000 cents. So this is our minimum value of NC, and we have found our third value of C, which is 89. The problem asks for the sum of our least values of C, which are 11, 88, and 89. They add up to 188. If you'd like me to solve any other AMC or AIME problems, please leave them in the comments.